Hello everyone, welcome to CHM Classroom with Auntie Taiwo. So today we'll be going to mole. Mole is a convenient quantity of particles. Then you can't do without mole when you're talking about particles. Then a mole is your Avogadro's number. That's your 6.02 times 10 raised to the power 23. So today I'm going to give you the 5 formulas of mole, although it's about 6 because we also relate mole during electrolysis. So we are going to give the 5 formulas of mole and how it can be applied. Yes, and that's why you need to get used to some of your units because there are some questions. Nobody will tell you that this is volume. Nobody will tell you that this is mass. Nobody will tell you that this is your concentration in mole per dm cube. Okay, so I'm going to give us about 5 formulas of mole. So maybe we are going to do maybe just one example before we leave the class today. Okay, so I can say mole equals to mass over molar mass. I can also say my mole equals to concentration in mole per dm cube times volume in what? dm cube. I can also say my mole equals to number of particles or atoms over the Avogadro's constant. I can also say my mole at STP equals to volume in dm cube over 22.4 dm cube. Then under my ID gas, I have PV equals to nRT. Yes, I have PV equals to nRT. So my mole is going to be what? N equals to what? PV over RT. Yes. Okay, then there's another one again. You have what? Mass over molar mass equals to IT over CF. Everything here is your mole. Under electrolysis, so I can say mole equals to what? IT. I represents your what? Your current. T represents your time. Then C represents your charge and F is the Faraday. This one is under what? Electrolysis. Where we still have a long way to go. So we won't be needing this at the moment. So we are just okay with these 5 at the moment. I have 1, 2, 3, 4, 5. Now there are some practical questions that they may give you that you will end up using 2 of those formulas before you arrive at your final answer. And there are some questions that are not even formula related. I call them relationship questions under stoichiometry. Now your questions can come in different ways. Your question can come in a way that you will be able to use the formula to what? To calculate. Either a straightforward question that you just use one of the formulas, or you use 2 formulas before you arrive at whatever you are being asked to find. Then we also have the relationship question whereby you have the mass to mass relationship, mass to mole relationship, mole to volume relationship, volume to mole relationship, mass to volume relationship, like that. So the question can come in different ways under your stoichiometry. So today I'm just giving us the formulas of mole. When next we meet, we are going to be solving some practical questions on the board. So please try and know this offhand, because standard questions under your SSC questions, your JAMB, your WAEC, you cannot escape questions like this. And so please, let's keep those formulas at the back of our heads. Let's keep it handful because we are going to be using them in subsequent classes. All right.